Okay, so 10.8 is going to be kind of a fun section. We do some very philosophically interesting things here. And as fun as it's going to be, though, I have to start out with an admission of guilt. And I'm not alone in this. Pretty much all your previous math teachers from me into the past, from elementary school on up, we've all been lying to you for a long, long time. There have been plenty of times, I'm sure, where you've heard this quote, "Square roots of negatives can't be done. Don't let the inside of a square root be negative. Can't do square root of a negative." You know, people mention this over and over and over again, and they even give you examples of why you can't do it. They say, just try. What number could it possibly be? Nothing's going to work. And unfortunately, this whole time, we've been lying to you. That is incorrect. There is, in fact, a way to do square roots of negatives, and the reason we've been lying to you all along is it's an extra layer of complication. It takes an extra complicated way of thinking about things that this isn't the first time we've sort of lied to you for your own benefit. If you think back to education in like kindergarten and first grade, nobody at that time even tried to talk about numbers smaller than 0. In fact, if you try to talk about numbers smaller than 0 to a kindergartner, they probably just laugh because it's a silly idea and it doesn't fit into their mental framework. And then it's not until later in elementary school that you learn about these negative number things that are smaller than 0. Well, we're kind of doing the same thing here. We didn't want you to be distracted with square roots of negatives, so we sort of put them to the side and ignored them for a while, but we're finally at the point in algebra where we really do actually need to know about them. So we're going to start talking about square roots of negatives today, here at the end of chapter 8, or chapter 10. So, first things first. The simplest possible square root of a negative of anything that you could possibly talk about would be the square root of -1, because -1 is kind of the simplest negative number. So what we do is we call the square root of -1 I. And this is a pretty standard mathematical trick. If there's a thing that you don't know what it is, and you're not even sure if it exists, and you're not sure how to work with it, you don't know very much about it, you just give it a name. I mean, we do this all the time with x. You know, you're talking about some word problem and you don't know what the answer is. Well, you call the answer x, and then you continue forward as if the x was an answer, and you fit it into equations and so on. Well, same idea here. Square root of -1, whatever the heck it is, we're just going to give it a name, and we're going to call it I. The letter I is going to stand for the square root of -1. The most important thing to remember about I, though, is not that basic definition there, but the more practical question of what happens when you square it. And depending on how you think about square roots, how well you understand that concept, this should have a really obvious answer. The square root of something, anything, is a number that when you square it, you get that something. Like if I asked you, what's the square root of 2,000? You don't know what the square root of 2,000 is. But if I said, what do I get when I square it? You would say, oh, you get 2,000. That's the whole point. Same idea here. I is the square root of -1, some magic number that when you square it, you get -1. So I squared's got to be -1 by sort of the definition of what square roots are. So if you want to memorize something about I, this is the thing to memorize. This you'll use far more often than the basic definition. And then what we do is we learn to do arithmetic using this new number, this number that we haven't run into before and we don't yet know how to handle. And the first thing that we actually do is kind of weird. We don't talk about adding and subtracting first and then multiplying and dividing and then exponents. We go right to exponents. We do exponents right off the bat, first things first with these. And the reason we do exponents with I right off the bat is because, well, honestly, they're kind of easy. If you're trying to figure out something like this example here, what the heck is I to the 7th? Well, what you do is you take I to the 7th and you break it down as a product of a bunch of other i's. How many I squareds can you get out of that? And there's one extra little I left over because 7 is an odd number. And then, because of this here, since I squared is negative 1, what we've got here is negative 1 times negative 1, oops, that's supposed to be a negative, times negative 1 times I. And you could do this with any power, right? No matter how large the exponent is, you could break it down as I squared times I squared times I squared, a whole bunch of I squareds, and then maybe, if it's an odd number, one more I at the end. Then the only thing you got to figure out is what happens when you multiply together 3 minus 1s. And you already know how to do that. Negative times negative times negative. You got 3 negatives. It's going to be negative times I, which, just like negative times x, you wouldn't say negative times x, you'd say negative x. Negative times I, you say negative I. So you might want to pause the video for a second, see if you can already do this one. I bet you can. And then press play again, and I'll work it out. Okay, so like in the previous one, we're going to break this down into I squared times I squared times I squared, and I'm not going to try and write them all out because there's a whole bunch of them, but the important thing is I to the 127 is odd, and since it's an odd number, we're going to have 1 left at the end. Now, how many I squareds did we have? So that's a relatively simple arithmetic question. Basically, the question is, how many times can 2 go into 127? It's a simple division problem. That goes in 63 times, with that one little guy left over at the end. So, remember, each of those I squareds is minus 1, so we have minus 1 to the 63. You had 63 I squareds, 63 minus 1s, and then times the one little extra I at the end. That negative 1 to the 63. 63 is an odd number. You have an odd number of minus signs, so this also comes out to be negative I like the previous one. As you work through the first few homework problems that have you do this kind of thing, you will start to notice a pattern, and it's a pretty interesting little pattern. I squared, well, I, we know, is the square root of negative 1. I squared came out to be minus 1. I to the third will come out to be I squared times I, which is negative 1 times I, which is negative I. I to the fourth will be I squared times I squared. In other words, negative 1 times negative 1, which will be 1. And then I to the fifth will be I squared times I squared, negative 1 times negative 1, times another I. In other words, 1 times I, it'll come out to be I. And then you're going to cycle back around. It's just going to repeat. It's going to be a cycle of 4 answers. Negative 1, negative I, 1, and then I. And then negative 1, then negative I, then 1, and I. And it'll just keep looping through those 4 answers for however many exponents you've got. So this is why we study powers first. They're actually kind of simple. There's only 4 possible answers, and you just sort of cycle through them and break out powers of 2, and it's fairly straightforward. Then we go to addition and subtraction. And addition and subtraction are going to be fairly simple. First of all, you notice I'm adding and subtracting a lot more pieces here. It's not just I plus I. There's some regular numbers in there like 2 and 3, and we've got things like 5i, which kind of talked about something times I just a moment ago when we did negative 1 times I, negative I. Well, 5 times I would be like 5 times x. It means I 5 times. Here, when you're adding together things like this, it's totally simple. You already know how to do this. You just collect like terms. You know how to collect like terms. You've been doing that since Algebra 1. And it was never even all that tough in Algebra 1. So here, if you collect like terms through this, the 2 and the 3 make 5, the 5i and the negative 2i, yeah, that's exactly what you get, 3i. Just like if it was 5x minus 2x, you'd say 3x. Subtraction, you might want to distribute the minus sign first, just like you would with polynomials. So you would have a negative 3 and a plus 2i. So this one here would add up to 2 minus 3 is negative 1. 5 plus 2i is 7i. So if you know how to work with x for adding and subtracting, from learning how to do polynomials back in Algebra 1, you can already add and subtract with complex numbers. No big deal. So let's see, we did powers, we did adding and subtracting. The next thing to take a look at would be multiplication. And again, you already know how to do this. You know how to FOIL things out. And that's exactly what we're going to do here. So first would be 2 times 3, and nothing new about that. 2 times 3 is still 6. Outside, 2 times negative 2i is negative 4i. Inside, 5i times 3 is going to be 15i. It's just like working with a variable. And then 5i times negative 2i is negative 10i squared. The only thing that's different from regular old polynomials is this. If you get I squared, like we did here, I squared is negative 1 because I isn't a variable. It isn't actually something like x. It's not an unknown. We know sort of what it is. It's the square root of negative 1. So if you say I squared, that's negative 1. So what we're actually looking at here is not 6 minus 4i plus 15i minus 10i squared. Oops, hold on a sec. Learn to write better, Mike. There we go. It's 6 minus 4i plus 15i plus 10, because negative 10 times negative 1 is plus 10. So when you go to collect like terms, don't forget to collect the 6 and the 10 at the beginning and the end. And you end up with 16 plus 11i. So adding, subtracting, multiplying, you know what comes next. Yep, dividing. We have to talk about division. And the nice thing about just about everything I'm teaching you here in 10.8 is you already know most of these steps. This is a square root. And we know we're not allowed to have square roots in denominators. We know that we're supposed to rationalize denominators. So as long as you remember that this thing here, that this is a root, and you remember that you have to rationalize the denominator, you'll be fine. You'll know what to do. Rationalizing the denominator is going to be sort of the tough case here because we have 2 terms in the denominator. And remember, when we were learning to rationalize the denominator, there was like easy ones, medium ones, and then hard ones, and this is definitely the hard case. The trick was, if you had 2 terms in the denominator, you would multiply top and bottom of your fraction by whatever it would take to make a difference of squares. So if this is sort of the a minus b part, then you would need the a plus b part. Multiply top and bottom by that, and that should produce a fraction with a denominator that doesn't have I in it anymore. It'll get rid of the root from the denominator. It's really important still to write parentheses squared and then put in the stuff that's getting squared, because it's really easy to make some fundamental mistakes here if you don't do that. So 3 squared, we know what that is. 3 squared is 9. 2 squared, we know what 2 squared is. That's 4. And I squared, I just said a second ago, remember this is the most important thing to remember, I squared is minus 1. So think about what's actually going on there in that denominator. You've got 9 minus 4 times negative 1. So it's really 9 plus 4, isn't it? Denominator is actually going to be 13. So you tried to create a difference of squares, and you actually ended up adding. And I know it's a little weird, but you'll get the hang of that pretty quickly. Up in the numerator, you're going to have to FOIL things out like we did in the previous problem just a second ago. So 2 times 3 would be 6. 2 times 2i would be 4i. 5 times 3 is 15i there. And then plus 10i squared. Again, and I'm going to mention this every time and try and make a big deal about it, I squared is negative 1. So when you go to collect like terms, you're actually got a 6 minus a 10 there. And then 4 plus 15, you get 19i. There is, though, one little thing about this answer we have here at the end. And it's kind of been hinted at by the way I've been writing my answers all along here. Remember when I did adding, we had a structure like this, and those all seem to have a particular pattern to them. These two things we multiplied, and the answer all had sort of a pattern to it. Even the two things we were dividing here had sort of a pattern to it. Well, that pattern is something called standard form. For complex numbers, you're always expected, when you're done, to write it in two parts. A part that doesn't have I, and a part that does have I. So there's the A part that doesn't have an I in it, and there's the B part that does have I in it. And that means the answer I currently have written isn't really quite in the right form. To write this in the right form, I have to break it up into an A part and a B part. And you wouldn't normally call that simplest form, because instead of one fraction, now we have two fractions, so that's not simpler the way we would normally think of simpler, but it is in what we call standard form. So it's a little counterinstinctive. You don't normally think to go this direction with a problem, but it is the correct direction to be working with it. One last thing before we're done. That is, why do we do complex numbers now? The reason why we do complex numbers now is because there's sort of a gap in our skills, and we need to sort of patch up that gap if we want to say that we know Algebra 2. If we've finished intermediate algebra, this little gap is not acceptable. And it has to do with quadratic equations. So here's a quadratic equation, and it's already been set equal to 0. And so we try factoring it, and factoring it doesn't go anywhere, honestly. So when you can't factor a quadratic equation, what you have to do instead is you have to use the quadratic formula. And just to remind you, because it may have been a while since you've thought about this, the quadratic formula looks like this. Negative b plus or minus the square root of b squared minus 4ac all over 2a. And if we use that here, the answer we get is going to be negative 5 plus or minus the square root of 5 squared minus 4 times 1 times 8. The coefficient there, a, that's 1, all over 2a. And when you work out the details inside that root, 4 times 8 is 32, and 25 minus 32 is a negative number. And we used to, back in Algebra 1, we used to say, oh, I was all done. This is a dead end. I can just say no solution. Well, hopefully, whoever your teacher was for Algebra 1, they didn't actually have you say, quote, no solution. Hopefully what they did was they had you say, quote, not a real number, because there is a solution, because we now know about this I thing. Is this a dead end? The answer now is no, it's not a dead end. You can't stop just because you see a square root of a negative. What you have to do is take that negative number, so we got negative 7 there, break it up as negative 1 times 7, and just like we've done in the past with other square roots, break that up as 2 square roots. And I squared is the new thing we've learned. That's, or I squared, square root of negative 1 is I. So we've got negative 5 plus or minus I times the square root of 7 over 2. That's not quite in the right form. Remember, I just mentioned this, quote, standard form thing, so you have to break that up into two fractions. One fraction looks like that, and the other fraction is square root of 7 over 2, I. So what this means is, when you're solving quadratic equations, you're never allowed to just stop and not provide an answer. If the square root comes out square root of a positive number, of course you have to simplify. And if it comes out square root of a negative number, you're not allowed to stop there either. You have to continue on and take the negative number and break it up into two pieces like we did here. So that's complex numbers, and that's why we learned about them.